Good morning, everyone. So let us just do a revision of whatever we have done last night. So first of all, we will start with the law of indices. Okay, very important law that will help you out in all kinds of mathematical explanations. It states that if your base is same, that means your x and x is same, then you can always add the powers. 3 to the power 6 multiplied by 3 to the power 5 is nothing but 3, 6 plus 5, which becomes 3 to the power 11, right? The base is same, 3 and 3. You cannot use this particular formula when the base is different, say 6 to the power 16. Then in this case, you will not combine any of this. You will just get a simple answer by squaring 3 and multiplying 6 16 times, which will definitely not come for your examination. Another one would be, even if there are negative signs, it doesn't matter. 4 to the power 6 multiplied by 4 to the power minus 5 is simply 4, 6 plus minus 5. And we have discussed about this. Plus into minus is minus. So 4, 6 minus 5, you are getting 4 to the power 1, which is simply 4 as the answer. Now, another rule of indices is based on your division. For example, you have x to the power m divided by x to the power n. So you have xm minus n. Example 2 to the power 6 divided by 2 to the power 5 is simply 2 to the power 6 minus 5 is equal to 2 to the power 1. So remember this simple thing, multiplication, right? Multiplication, you have to add the powers, whereas in division, you have to subtract the powers. Simple as that. Even if they're negative here, 2 to the power 6 divided by 2 to the power minus 4, it simply means 2 to the power 6 minus minus 4. Minus into minus is plus, 6 plus 4 is equal to 2 to the power 10, and this will become the answer. So remember these two rules. This will be really helpful whenever we are doing any sort of arithmetical problems. Now the next one that we have discussed is finding the squares of numbers. You can do, say, if you want to find 32 square, you can do 32 into 32, right? That means 32 into 32, 2 to the 4, 3 to the 6, 3 to the 6, 3 to the 9, 4, 12, 1, 0, 2, 4 to the 6, 3 to the 6, 3 to the 9. Right, so this is what you can do. Or you can do it using the formula or using the shortcut. So you take the ones digits, right? You take this digit. What is 2 square? 2 square is 4. Now it is single digit, so that's why I'm putting 0, 4. Next, take this 3. What is 3 square? 3 square is 9. Okay, 3 square is 9. 904. Now in the second step, you multiply the digits. 3, 2 are 6, and again you will multiply it with 2. That means 3 into 2. These are the digits. Multiply it with 2. You will get 3 2 are 6, 6 2 are 12. 4, 2, 1, 0, 2, 4. So this is using the formula. See, this is a square. This is b square. And this is 2a and b. I'm taking this as a, I'm taking this as b. So instead of going through the motion of a plus b whole square, what I've done is I've taken the ones digits. 2 square is 4. The tens digits, 3 square is 9. I've multiplied the digit 3 2 are 6 and then multiply it with 2 again. And this will be value for every single 2-digit number as well as your 3-digit or any digit number. You can always use this particular method to solve your problem. Now this is also correct, okay? This is also absolutely correct, okay? If you're comfortable with this, then this is also absolutely correct. Why I'm teaching you this method is because sometimes your squares may take a little bit of time, so you can always use this particular shortcut to get the squares of any number. Now let us go to finding the square root of perfect numbers, right? So say 1024, the square root, the square that we have just found out. Let's do it by using the LCM method first. 2 5s are 10, 2 1s are 2, 2 2s are 4. Every even number is divisible by 2, 2 2s are 4, 2 5s are 10, 2 6 are 12, 2 1s are 2, 2 2s are 4, 5 2 8s are 16, and we have 2 6 are 12, 2 4s are 8, and we have 2 3s are 6, 2 2s are 4, then 2 16, then we have 2 8s are 16, then we have 2 4s are 8, and then finally 2 2s are 4. Now you will join them in pairs. 1 pair, 2 pair, 3 pair, 4 pair, and 5 pair, which means you have 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 2, which is nothing but 2 to the power of 5, which is 32. So you're getting this answer. Always remember, you just have to pair it up and write it only one time. Okay, so your square root of 1024 is nothing but 32. Now similarly, if I have to use another formula, not another formula exactly, okay, let me just go to another page. Long division method. If I have to use your long division method, what I will do is I'll write down 1 0 2 4. I will pair them up, right? I will pair them up in twos and see which square will be closest to the number given. Now 2 square is 4, very far. 3 square is 9, very close to 10. 4 square is 16. I cannot take this because this is greater than 10. So I will take this particular value. 3, okay, 3 square is 9, right? Now you will subtract this. 10 minus 9 is 1. This will come down as a pairs. 124, you will add this one. 3 plus 3 is 6. Now you are going to input one value that will either give me exact 124 or something close to 124. So let's say 61 into 1. I'll get 61. I will not take that one. 62 into 2 is 2 2s are 4, 6 2s are 12. Right? So if I put 2 here and 2 here, that means whatever you put here must be inserted here too. So you will write down 32, 124, and hence you will get the square root of 1024 by the long division method as 32 once again. The long division method is valid for every single number, whether you want to find it in terms of decimal, whether you want to find it in terms of square root. Though it is a little bit longer, this will always give you the result. In the LCM method, you cannot find a decimal using the LCM method. So that is the only drawback. However, we would like to believe that during our examination, because the long division method takes a very long time to solve, they will give you perfect square numbers, which by using the LCM method, you will be able to find the answer. There is nothing wrong with the previous method, nothing wrong with this current method. You practice and see which one you are more comfortable with, and then you can always go with that during the examination. Let's see what happens when there are no perfect square numbers, right? So for instance, if we get a number like 290, what do you do? Now I can use 2 1s are 2, 2 4s are 8, 2 5s are 10, 5 2s are 10, 5 2s are 10, 5 9s are 45. So in this case, you will not be able to find any common pairs. You will not be able to put anything. So you will have to use the long division method. 290, you pair it up. If there are no number here, it means there is 0. Okay, so you can always pair it up like this. Similarly, 1 square is 1, right? 1 square is 1. You add 1 here. It becomes 2. I have to insert one number here. 2 minus 1 is 1, bring it down, 190 together. Now say 23 into 3, 3 3s are 9, very far, so say 5. 5 5s are 25, 5 2s are 10, 125, it is getting close now. 7 7s are 49, 7 2s are 14, 189. So you find that 17 will give me 189, and you write down 7 and 7. 1, you put a decimal point here and bring down 2 zeros, okay, not single zero, you have to bring down 2 zeros. 14 3. Now in this case, what happens is 34, whatever number you put here, right, apart from 0, you will get something smaller. So you will write down here 0, and then I will write down here another 0, and I will bring down 2 more zeros. Okay, now you will have to find out 340, something that will get you close to 10,000. So say 4 4s are 16, 4 zeros are 0 1, 4 4s are 16, 4 3s are 12. So this is too big. 3 4 0 3, 3 3s are 9, 3 0, 4 3s are 12, 3 3s 9 10. So that means our answer would be 2 here. Now once you get this now up to the second decimal digit, you can stop. Okay, no need to go, otherwise it will become very long. Our remainder is irrelevant in this matter. So your root 290 can be written as approximately 17.02. Now you can see, right, sometimes this question will go on for a very long time. So in your examination, because it is for a limited number of time, you will probably not be asked such kind of questions where you have to use long division method to find the answer. However, it is imperative for us to know all these methods so that any day you are asked this type of complete questions, you should be able to answer it. Now another way of finding out the square root, okay, representation is using, okay, let me give you another example, say 450. Now same thing, 2 to the 4, 2 to the 4, 2 5 are 10. Is it okay? 2 to the 4, 2 to the 4, 5 to 5 are 10. Next 5 6 7 8 9, so 3 7s are 21, 3 5s are 15, 3 2s are 6, 3 5s are 15, and then you have 5. Now you can see that there are two pairs that are formed, 3 and 5, and this is left out. So what you will do is you will write down all the pairs, and whatever is unpaired you will multiply them. In this case only 2 is left out, so you can write it as 15 root 2. Therefore the square root of 450 is nothing but 15 root 2. So in this way you can represent this in terms of a root. Now this is more popular, okay? This type of question is more popular in your examination than the long division method, because through this you can do rationalization and you can form different questions. So I would suggest that you get used to writing your square root in terms of this formation, right? In terms of this formation for different questions. Say again, let me take 720, okay? Same, 2 3s are 6, 2 5s are 10, 2 3s are 6, 7, 2 6 are 12, sorry. Then 2 1s are 2, 2 8s are 16, 2 90, okay. Then you have 2 45, then we have 3 15, and 3 5s are 15. See the pairs, 2, 2, and 2. Once again, you have 2 into 2 into 3 root 5. 3 to 6, 12 root 5. Okay, so in this way, you should be able to get the answer. Okay. Okay. So this is how you can represent your square. This is how you can represent your square root. Okay, I think I've erased it. Okay. Anyway, now finally, we have to go to the significant digits, right? Significant digits, very simple. If you have any number with decimal points like this, 2.3567, what you will do is, for the third significant digits, you will go 1, 2, 3 and see the number just after the third digits. If that number is greater than or equal to 5, you will add 1 to the previous digit. So in this case, 7 is greater than 5, so 3, 5, 7, okay? So this will become the answer in third significant digits. Similarly, 2.356, if I say second significant digits, then 6 is greater than 5, so you will add 1 to 5 again, 2.36. Similarly, if you go first significant digits, see, 5 is equal to 5, right? 5 is equal to 5 is equal to 5, so you will write 2.4. And finally, see, 4 is smaller than 5. 4 is smaller than 5, so your 2.4 simply remains 2. Now this is going to be valid only when you have this particular word approximate in the question. If you don't have the word approximate in the question, then you are never going to approximate or put it in the significant digit format. Otherwise you will not get the right answer. It might be in the option, but it will be completely wrong. Always remember, whatever answer you get may not be the answer, right? They also know what you can come up with, the mistakes that we make. Okay, so this is the most common mistake that we made. Okay, always remember, as long as approximate is not written in the question, please do not make use of these significant figures. Otherwise you will get an answer which may be in the option, but it could be completely wrong. Finally, we have done some few other miscellaneous properties like anything, okay, anything to the power 0 is 1. So which means that 2 to the power 0 is 1, 1 million to the power 0 is 1, 1.77777777 to the power 0 is still 1. Always remember this, anything to the power 0 is 1, as well as anything, okay, anything multiplied divided by 0 is either undefined, infinity, or none of the above if given in the option. You cannot divide anything with a 0. So that's the reason why in the question, if you find out such problems where in the denominator you get a 0, it means that NOTA would be, that is none of the above, will be the answer. Or if undefined is the answer, then this would become the correct option. Now similarly, we have I think anything to the power, anything divided by 0. Let me check once again what miscellaneous chapters that we have done. Okay, what miscellaneous chapters that we have done. Properties, yes, base square. Suppose you get a formula for a formation at 2 to the power x by 3, 2 to the power 5, right? When the base is same and there is an equal to sign, you can always equate the powers. That means x will be equal to 2. So this is possible only when the base is same and then you have an equal to sign. Only then this particular formation will be possible. Now, whenever you have things like x squared is equal to 144, when you have to find the value of x, you need to take these two to the other side. So when squares goes to the other side, it becomes square root, and when square root will go to the other side, it will become a square. So whenever you are changing sides, your plus becomes minus, minus becomes plus. Multiplication becomes division, division becomes multiplication. Your square becomes square root, your square root becomes square. Okay, so always remember this. Maybe I can give you an example on multiplication becoming division. Say 2 into no, sorry 3x divided by 7 is equal to 21. So what you will do is, see, this is division, right? I want to find the value of x. This is division. When it goes to the other side, it becomes 21 into 7. This is multiplication. When it comes to the other side, it becomes division. 3 7s are 21, 7 7s are 49. Okay, so in this way, your changing sides were x plus 3 is equal to 72 plus y. So when y goes to the other side, it becomes minus because this is plus here. Plus 3 will become minus because it is plus here. Then you will get 69. So in this way, you also have to remember the sign formation or the sign changes when, or the operation changes when it goes from the left hand side to the right hand side. Okay, so in this way we come to the end of our revision classes. I hope that you are doing your homework. I'll soon share your feedback on the homework, as well as if possible I'll make a video on how to solve the homework. Have a nice day, everyone.